Okay, now we're actually going to apply our knowledge of radicals and rational exponents to solve radical equations. That's what we're going to do today. The key points, the key steps for today is you're going to always want to isolate the root, get it by itself using just algebraic methods. Then you want to raise both sides to the reciprocal power. Remember, when you take a power to a power, it's going to multiply those two, and that's going to make everything just a 1 for your exponent, which is exactly what you want. And then you can just solve, and don't forget to check for extraneous solutions. The little asterisks here, the one thing we have to watch out for, when we raise both sides to the reciprocal power, what we're actually doing, as we talked about, is sometimes we can end up taking a square root of both sides, or a fourth root of both sides. So whenever we're taking an even root, whenever we're doing that to both sides, don't forget you have to add plus or minus. So, for example, just a quick example here, if you have x to the 2/3, to solve that, you would take both sides to the 3/2. Take both sides to the 3/2. Okay? And if we look at this, if we remember, the 2 represents the type of root. So it turns out we are taking the square root of both sides. So in that case, you take the reciprocal here. These would all just become 1. So you get x equals plus or minus 1. Okay, this case over here, y to the 4/5. So you take both sides to the reciprocal power. So the 5/4. 5/4 on this side. So let's take a look. Again, this is an even number down here. This is an even number. So it ends up we're taking the 4th root of both sides. So if we're taking the 4th root of both sides, we do indeed need to add plus or minus. Same thing over here for this third example. We would take both sides to the 9/8 power. The 9/8 power on both sides. Let's examine if we need to do a plus or minus. Well, I look here, my denominator is even, so we are taking an even root. We're taking the 8th root of both sides. These guys would just become 1 over here, so we would get z equals. And then since it's the 8th root, we would indeed add plus or minus. Now let's look at this last example. It's the 7/2. So we take both sides to the reciprocal power, 2/7. That's not a z, it's a 2. So 2/7. 2/7. So this last example, we look, and are we taking it to an even root? See, that is 7. So that is an odd root. So we're taking the 7th root of both sides. 7th root of both sides. So, because it's odd, we do not need to add plus or minus. So this last one we do not. But all the other ones, 8 is even, 4 is even, 2 is even, we all need that plus or minus right there. Also, one more thing to remember here. When we have roots, just remember you can write it as, when you have a square root of x plus 1 equals 2, you can also write that as x plus 1 to the 1/2, or vice versa. So this is the same as this. Same thing here. If you have a y minus 5 to the 1/3 equals 5, that's the exact same. That's a 3, so that's the same as the cube root of y minus 5 to the 5th. Same thing here. Z plus 8 to the 4/5 equals 1. That's the exact same thing as having the 5th root of z plus 8 to the 4th power. And the 4 could be either inside the root or outside the root. So just remember, you can either have the fractional exponent or just the root here. And why don't we just go ahead and just take a look at what you would do here. Remember, if this is a 1/2, you take both sides to the reciprocal power. So 2/1, or just 2. Okay. This one, again, you would take both sides to the reciprocal 1/3. Reciprocal of 1/3 is 3/1, or just 3. And we're not going to solve it. I'm just letting you know, a preview for what we're about to do. And finally, the reciprocal 4/5, you take both sides to the 5/4. 5/4. So only in this last case, like we just talked about, only in this last case, you have a 4 in the denominator here, so you would actually add a plus or minus right here, plus or minus 1. The other ones you would not, because there's no denominator that is even right there. So only in this last case. Okay, let's go ahead and try a couple problems now for real.